Okay, all right. So if you need to pause read, this is more of a challenging average speed problem. So I highly encourage you kind of read with me and then hopefully keep up with the thought process here. So here it says a particle moving on a straight line. It covers half the distance with a speed of 4 meters per second. And it says the other half of the distance is covered in two equal time intervals with speed of 5 meters per second and 7 meters per second respectively. And it wants us to find the average speed of the whole entire motion. So as you can see here, we have three different segments because I see that four different speeds are given. Okay, 4, 5, and 7. All right, so let's go ahead and do it. So this particular first strategy, it just, well, hopefully if you practice, you'll kind of see and understand a little better. I'm just going to give you a visual here. The problem states that a particle is moving in a straight line and it covers some distance. It never said how far it is. So for this one, I'm actually going to call it 2D, okay? Now, in case you're confused and like as to why 2D, why not just D? I'm calling it 2D because the problem states that it covers half of the distance with the speed of 4. So if I call it 2D, I can say the first half is just D, okay? So if you look at my diagram here, right? If you call the whole entire length 2D, then half of 2D would just be D. So it just allows you to avoid fraction. Could you call it D? Yeah. If the whole entire length is D, then half of D would be D over 2, which involves fraction. Okay? Which is not wrong. It's just it's entirely up to you how you see this problem. So I'm going to kind of quote-unquote outsmart a little bit. I'm just going to call it 2D. So therefore half of the total distance for the first leg would just be D. So here in my work, D1 is just D because that's half of 2D. Now, what else do I know in the first segment? The first segment, the speed is given as 4 meters per second. Okay. What do I know what the time is? I don't know what the time is, right? In order to find time, you need to know both speed and distance, but in this case, D1 is kept as an unknown quantity, which is just D. So I'm just going to call T1 T1 because I don't know what it is. It's not given to me. Now, let's move on to the second part. It says the second half of the distance is covering two equal time intervals, right? Of 5 and 7. Okay. So what's D2? I don't know. What's S2? S2 is given as 5. Well, I don't know what T2 is because D2 is not given to me, right? So it's okay to label these quantities as unknown, right? Don't force it, because otherwise you just drive yourself crazy. Well, what do I know about the third segment? The third segment, well, do I know how long it is? No, I don't. So I'm just going to call it D3. Well, what I do know is speed for the third segment because it's given in the wording here as 7. What's essential too is this wording here in the second sentence. It says the other half, right? Half of the distance covered in two equal time intervals. Equal time, so that's essential for this problem. So I'm going to call it T3. But T3 is also equal to T2 because it said so, right? This is kind of an essential piece of information. It says equal time intervals. So whatever T2 is, T3 must also equal to the same amount. So if you pay attention thus far, the first half of the distance is just called D. The second leg here, I just call it D2. And as you can see here in green, the length of D2 is shorter than the length of D3 because you're moving at the same time at a slower rate, so therefore the distance should be shorter. Why is D3 longer? Well, it's the same time, but you're moving faster. So if you're moving for the same amount of time at a faster rate, you should cover more distance, okay? That is why D3 is longer, because it's moving at a faster rate in the same amount of time. All right, so hopefully that makes sense. If not, listen to it again. All right, so let's go ahead and focus on what it's looking for, though. All right. So this problem, like I said earlier, it's challenging because it requires you to kind of set things up and trim away at variables. Well, it wants us to find the total average speed for the whole entire motion. To do so, you need the total distance divided by the total time. Well, and according to my decision here, right, my choice, well, what did I say D total to be? Well, I decided to call it 2D. So instead of D total, I'm just going to call it 2D. Well, what's T total? T total using common sense, it's just time of the first leg plus time of the second leg plus time of the third leg. However, I highlighted T3 here because this is once again an essential piece of information where I'm circling back and forth with my cursor. It says that it's travel in equal time, right? Not equal distance, equal time. So whatever T2 is, T3 must be the same amount, hence equal. So instead of saying T3, I can replace T3 with T2 because it said so. Well, now you notice here, I haven't done anything to the numerator because the numerator is just the total distance. But in the denominator now, I have T1 plus T2 plus T2. Well, you have a T2 and a T2. Those are like terms, so condense it, combine it, combine like terms. So if I combine like terms, I have 2D, that remains the same. T1 hasn't changed. So I'm just going to add T2 plus T2 makes 2T2. So in order to find average speed total, I need to know what the distance is. I need to know what T1 is and T2. So here you have three unknowns in one equation, which is impossible to solve, right? So this hopefully forces you, I like to use it to set up each leg and then trim things down slowly. And it's going to take a little practice for you to do this. So let's focus on the first segment. Okay, the first segment, do you know what the distance is? No. You just know that it's half of 2D, which is D. You know the speed, you don't know what T1 is, and it's okay. Just write it out. So S1 is equal to distance over time. Okay, well, here I want to swap T1 and S1. I want to multiply both sides by T1 at the same time, divide both sides by S1. Or I got to think T1 just move to the top left, S1 move to the bottom right. So here I have T1 is equal to D1 over S1. Well, what's D1? D1 is just D. Once again, the first segment is half of 2D, which is just D, right? 2D divided by 2 is just D. That's why this is now just D without any subscript. So all I did was I replaced D1 with D because that's a true statement. Well, what's S1? S1 is 4 meters per second. So I'm just going to leave the meters per second out here, just keep my equations clean. So I want to move on to the second half, okay, or the second leg. Well, what do I know about the second leg? I want to start with the same statement. Speed is equal to distance over time. So it'd be S2 is equal to D2 over T2. Okay. But here, though, I want to solve for D2, not T2. There's a reason why, right? So hopefully with practice, you kind of understand why you would do certain tasks. Here, I want to solve for D2. Well, what's S2? S2 is 5 because it's given. So to solve for D2, multiply both sides by T2. Hence, if you substitute out S2 for 5, it stays. And multiplying both sides by T2 would leave you with 5T2 equals D2. Okay, now let's move on to the third leg. For the third leg, I'm also going to start with the same stuff. It'd be S3 is equal to D3 over T3. Okay, well, what is S3? S3 is simply 7. So to solve for D3, I would just multiply both sides by T3. So once again, the 7 comes from the problem. It says S3 is 7. Okay. Now, in case you're confused, well, why did I solve for T1, right, using the information in the first leg, but yet here I solve for D instead of T? Well, I solved for D2 here and D3 here in my last steps here. It's because I know that, watch my cursor, if the whole thing is 2D, well, this is D, from here to here is also D. Well, I can say that D is D2 plus D3, right? So I can make a statement, okay? I can say, oh, by the way, in case you didn't keep up with this whole T3 is equal to T2, I just replaced out T3 with T2 because that's a true statement. But the bigger picture is I can say D is D2 plus D3, okay? So if you take the green segment, which is D2, you add it to D3, the purple segment, you should just get half of the total distance. In this case, half of 2D is just D. Hence, D is equal to D2 plus D3. Well, what's D2? Well, I just solved for D2 here in terms of T2. Well, I can resubstitute out D2 for 5T2. At the same time, I can substitute out for D3 for 7T2. Okay, so instead of saying D2, I'm just going to say D2 is 5T2. So instead of D3, I'm just going to say D3 is 7T2 because they are equal to. So as you can see, you have 5T2 plus 7T2. You can just combine like terms, Therefore, D is just equal to 12T2. Okay. Now, what do you do with that? Well, light work. Solve for T2. Why? Because in this denominator here, yeah, you have a T1 and you have a T2. Well, using the information in the first segment, I already isolated for T1. T1 is D over 4. Using the information in the second and third leg, I can solve for T2. Well, now that I know T1 and T2, I can substitute out T1 and T2 in this starting statement. So, the numerator hasn't changed. I'm going to keep 2D as is. Instead of T1, I want to say T1 is D over 4. Once again, because T1 is D over 4. And instead of saying T2, I'm just going to substitute out T2 for D over 12. So the 2 I carried over, but instead of saying T2, I'm going to say T2 is D over 12. So as you can see here, 2 and 12 cancels out. So it leaves this which is D over 6. Okay. So I'm just going to carry my work down here. Numerator hasn't changed. So it would be D over 4 plus D over 6. As you can see, both of the fractions on the bottom have a D. You can factor out D, and that D will cancel with the D in the numerator. So hopefully at this point your algebra skills on point. So I'm just going to cancel out just a D. So visually, just because you cancel a D doesn't mean there's no number there. There's a 1 there as a placeholder. So it would just be 2 over 1 over 4 plus 1 over 6. But in order to add the two fractions on the bottom here, you have to find common denominator. So I'm just going to go ahead and use 24 as a common denominator. So I'm just going to multiply the first fraction here by 6. I'm going to multiply the second fraction by 4. That will just give me a common denominator. If you want, you can just do 12. It doesn't really matter, okay? It will all come out the same. So 2 in the numerator, multiplying the first fraction by 6 in the numerator, multiplying the first fraction in the denominator by 6, so it would be 6 over 24. Likewise, the second fraction, multiply top by 4, multiply bottom by 4, so it would be 4 over 24. At this point, as you can see, it would be 6 plus 4, which is 10, and the common denominator is 24, but then you have a fraction. It would be 10 over 24. Well, when you divide by a fraction, you would multiply the reciprocal. So it would simply be 2 times 24 over 10. So 2 times 24 is 48, and then that would be over 10. And 48 divided by 10 is just 4.8, okay? So if you need to keep up with the algebra, or fraction here, please make sure you do that. But the answer here is 4.8 meters per second, okay? So that's the answer for this one. Now, here's a different strategy or perspective, if you call it that. Now, what if you had called it the whole entire distance d, right? Again, I call it 2d just because through practice I know what I can avoid, right? I don't like fractions when I can avoid them. What if you call it d? The whole entire distance is d. Well, if you call the whole entire distance d, then, well, the first segment would just be half of d, it would be d over 2, right? Same information here. S1 is still 4, T1 is still unknown. Well, what's D2? D2 is still unknown, so I was calling D2. What's S2? Still 5. What's T2? Still T2. Well, what's third segment? I don't know. I just know that the distance are different, right? D2 and D3 cannot be the same because they move at the same time at different speed. If you move with the same time at different speed, you cannot have the same distance. Okay, so don't assume that D2 is equal to D3. Not for this one. It's entirely different. So what's D3? I don't know. What's S3? I do know. That's 7. What's T3? I don't know. Okay, so it comes back to, once again, the same starting point. In order to find average speed total, you need distance over time. Well, what's D total for this particular reference point decision? Since I call the whole entire trip D, the numerator is just now D instead of 2D like the previous strategy. Well, the bottom hasn't changed. T total is still T1 plus T2 plus T3. But it comes back to the statement. It sets that the second half of the distance is covered in 2 equal times. So T3 is still equal to T2, right? Otherwise, that statement is false, but it's the condition that's given. So I'm going to replace out T3 for T2. I'm still going to combine like terms just like the previous strategy. So you notice here, you run into the same really roadblock. It's still D over T1 plus 2T2. So if you caught up with the first strategy, don't panic. Just start setting up each segment and start trimming down unknowns. Okay, and it's going to take a little practice. Well, S1 is just D1 over T1. Well, why is my numerator d over 2? That's because d1 is half of the total distance. And the total distance in this case is just d. Therefore, dividing d by 2 is half. So instead of d1, I just call it d divided by 2. So here you have a fraction divided by a whole, so you just combine the two denominators. So make sure, once again, your algebra is solid on this part. So instead of saying d divided by 2 divided by t1, I can just say d divided by the product of 2 times t1. So I want to move on. Okay. Second segment, S2 is equal to D2 over T2. Well, what's S2? 5. What's D2? Don't know. What's T2? Don't know. Okay. Well, what I want to solve for? D2. So D2, once again, is 5T2. Well, what can I do with the third segment? S3 is equal to D3 over T3. But keep in mind, once again, T3 is the same as T2. Okay. Well, what's S3? 7. What's D3? I don't know. What's T3? I don't know. But what I can do is, once again, solve for D3. Okay. And keep in mind, even though it says here T3, you can substitute out T3 for T2. So here, I'm just going to say, instead of saying 7T3 is equal to D3, well, because T3 is equal to T2, I can just say 7 times T2 is equal to D3. And it comes back to this, right? Well, if the total length is D, green D2, purple D3 must add up to equal half of that. So half of the total length, which is D over 2, must equal to D2 plus D3. Well, I can substitute out D2 being 5T2. I can substitute out D3 now for 7T2. So once again, you have two like terms here, 5T2 and 7T2. You can combine that. That'll be 12T2. So if we clean up a little bit, it would just be D is equal to 24. It's 24 because, well, this is 12T2. And then to get D by itself, you would multiply both sides by 2. So therefore, 12 times 2 is 24. Okay, that's where the 24 comes from. Well, what do you do with this? Well, you can just make a substitution. Now that you know what D is equal to, you can say, well, I can just substitute D out for the first leg. So instead of saying 4 is equal to D over 2T1, you can substitute D out. You can say 4 is equal to 24T2 divided by 2. Okay? Now, you can clean it up a little bit. So, if you like, you can cancel out 24 divided by 2 is just 12. Right? So here, I'm just going to do a little swap. I want to move for T1 up to the top left. I want to move the 4 down. So it'd be 12 divided by 4, which is just 3. So if this part loses you, just do the algebra on your scratch sheet of paper and you should come to the same conclusion as I have. So I can say T3 is 3T2. Well, what do I do with that? Well, I'm just going to go back and just substitute it out. Okay, so in my original statement, I have D, which is my unknown. I have T1, which is also a second unknown. I have T2, which is also a third unknown. But what I can do now is just trim it. So what is D? D is 24T2. Well, where did I get that from? Right here. Watch my cursor in the black here. Using the information in the third and second leg, I can draw a conclusion that says D is equal to 24T2. So instead of saying D, I can substitute it out for 24T2. Well, what's T1? I don't know, but I just solved for it down here. I can say T1 is 3T2. Okay, so hence, instead of saying T1, I wrote T1 as 3T2 right here, where my cursor is. And the 2T2 remains. At this point, hopefully you're catching on. You have a T2 on top. Both these terms on the bottom have a T2. So you have a common variable. So you can simplify it, okay? So, numerator, 24T2 gets carried down. Well, 5T2 plus 2T2 is 5T2. Let's see, right? I think I said that right. 3T2, excuse me. Plus 2T2 is 5T2. Well, T2 on top, T2 on the bottom cancels. So that would just leave you with 24 divided by 5, which gives you the same answer of 4.8 meters per second. Okay. So ultimately, the goal here is just to trim down functions by replacing it with true statements. And this is a harder problem because there's a lot more substitution to do. But as you can see, there's at least a couple of different strategies here that allows you to do so. Okay. I hope that helps. Stay nerdy, don't be wired.